Hello and welcome to part 2 of our special Q&A Hubblecasts. In the last episode, we looked at some of the more technical questions that you sent us. And in this episode, we'll get to the science questions. Lots of the questions we received had something to do with the Big Bang. Really a lot. So let's start there. Many people picture the Big Bang as some sort of explosion, and then ask, where did this explosion take place? Or where is the universe expanding from?
If the universe is expanding, what is the center point of the expansion?
The answer is everywhere. Now the key is to realize that the term Big Bang does not describe an event in space, but rather one in time. The Big Bang was not an explosion. It was an event that happened everywhere at the same time, and the universe was infinitely large right from the start. And so there is no single point from which the universe is expanding. And also, there is no center. It is simply impossible to define a center in an infinitely large space. But you may have heard people talking about the center of the observable universe. Now that does make sense.
With all the charting of the universe in 3D, where is the center of the observable universe?
The universe as a whole does not have a center, but the part of it that we can observe does. The observable universe is the part of space that is physically possible for us to see. All the light emitted in this region has had enough time since the Big Bang to reach Earth. This region is a sphere with us at its center, but our position has no particular significance. If there are astronomers in some distant galaxy, then they will also be at the center of their own observable part of the universe. Like a sailor at sea, we are always at the center of our own horizon.
Now this is of course somewhat related to your questions about how far Hubble can see. These images show some of the most distant galaxies that have ever been observed, going back an incredible 13.2 billion years, to a time when the universe was only about 500 million years old. So this is pretty much at the limit of what you can do with Hubble. We know, however, that the most distant objects identified with Hubble are not the universe's first. To spot these, we will need Hubble's successor, the James Webb Space Telescope, which will be able to peer even further back into the history of the universe.
Would it be possible to build a new Hubble with more advanced instruments and larger than the current technology? A Hubble that could see beyond the boundaries of the universe?
No matter how big or how powerful your telescope, because the age of the universe is finite, there is a fundamental limit to how far you can see. Now another topic that you really wanted to know about is the expansion of space. Specifically, if the universe is expanding, how can two galaxies nevertheless collide?
If the universe is expanding in all directions and everything is getting further away from everything else, how is it that galaxies can still collide?
Well, although the universe is expanding as a whole, that does not mean that every part of it is expanding. For example, this room is not expanding. Neither is the solar system, nor the Milky Way. These structures are held together either by the electromagnetic force or by gravity. So while on average the distances between galaxies become larger as the universe expands, two nearby galaxies can nevertheless attract each other until they collide. This is not a contradiction. But now let's move a little closer to home.
With Hubble able to see so far, why do we not get more pictures of our own solar system?
Are there any Hubble pictures of Pluto?
Some of you wanted to know why Hubble has not looked closely at the planets and moons in our own solar system. Well, for the most part, it has.
Hubble cannot observe our Sun, or the closest planet, Mercury, because its instruments are light sensitive and would be damaged. However, the telescope has examined every other planet in the solar system, including dwarf planets, Pluto, Ceres, and Eris. But of course, Hubble does not just produce pretty pictures. It provides planetary scientists with vital information about our neighbours that may help us better understand our own home planet, Earth.
But what about beyond the solar system? Before the launch of Hubble, we didn't know about the existence of extrasolar planets. But of course now, astronomers are finding them everywhere.
How many possible planets with life has Hubble discovered?
Can Hubble view in detail the planets that orbit other suns?
Now Hubble has played some part in discovering some of these planets, but other space telescopes, such as Kepler or Corot, are much better at this, because they were specifically designed for this purpose. Hubble's forte lies more in the measuring of the atmospheres of these planets.
Astronomers study planetary atmospheres using a technique called transmission spectroscopy. They watch as a planet crosses in front of its parent star, and some of the dazzling light from the star passes through the rim of the planet's atmosphere. Any molecules in the atmosphere will absorb some of the starlight, leaving distinct signatures in the light that reaches Hubble. So far, Hubble can't quite do this for planets as small as Earth. But astronomers are getting there fast, and on larger planets, they have already found water vapor, oxygen, and methane, all of which play key roles in life on Earth.
You're inside a big balloon, which is expanding more and more. This means the wrap of the balloon is moving away from you. But what could be beyond the wrap? What could be beyond our expanding universe?
There were, of course, a lot of questions that we've not had time to get into. But among the questions, there are also a couple of misconceptions that I would like to talk about. One example is the inflating balloon analogy of the expansion of space. The idea here is, of course, that the surface of the balloon represents a two-dimensional version of the expanding universe. Now, for this analogy to work, you should imagine yourself being a two-dimensional creature living on the surface of the balloon. Now, the key is to realize that the third dimension, i.e. up or down, is not needed to describe any of the physics that goes on in your universe, i.e. on the surface of the balloon. And so, for the purpose of the analogy, the third dimension does not exist, and to ask what the balloon expands into is therefore entirely meaningless. Similarly, to ask what our 3D universe expands into, or what lies beyond our universe, is just as meaningless. And then there's the issue of the infamous fabric of space-time.
According to relativity, space-time consists of a fabric. What then is the size of this fabric, and how can it be observed?
Many of you will have seen this illustration of the fabric of space being bent by a mass. Now the trouble is, of course, that space is not a fabric, or a sheet, or a trampoline. We just need this 2D analogy of a sheet to visualize the concept of a curved space, because a 3D curved space is something our mind has significant trouble with. Now don't feel bad about that. Physicists and astronomers work with these concepts all the time, and they understand them really well, but even they have trouble visualizing them. So we do need the analogies to help us develop our intuition. But the trick is to know where the analogies break down and which aspects of reality they capture and which they don't. And now to finish with the ultimate question. What is the meaning of life? Well, the meaning of life is... This is Dr. J, signing off for the Hubblecast. Once again, nature surprised us beyond our wildest imagination.
Now that you've caught up with Hubble, make sure to get the latest from the ground too. The ESOcast highlights the best of the European Southern Observatory and its powerful telescopes that observe from high in the Chilean Andes, at the Southern Hemisphere's best-known sites for astronomical observations.